Oh, this is something cool.
Something really cool.
Okay. It's not going to stand tonight because we basically removed one of the legs to rebuild him to make him stronger. We've also given him a name. His name is Watson. I know, but Watson is obviously an acronym for.
Don't tell them what it's for.
I'm not going to tell you. Go on the website. You'll see. But what I really want to show you is the difference between the two legs is starting at the knee and working up to the hip. Had some problems with this original design where the belts between the two pulleys was too short. Put a belt tensioner in there, and I also couldn't put the rod in that prevents the servo from having a lot of stress on it. So this one here, my assistant will hold it up. I'm just going to lay this down for a second. Hard to hold the mic in this way. Hopefully next month we'll have the other leg done and it'll be much improved. So here, what we're trying to do is strengthen up the mechanism. We've put joints in with bearings in them as opposed to just bushings. And we've created this little rectangle here that supports the servo, because these hobby servos are very, very weak. Designed this belt tensioner so we can put a lot of tension on the belt, and any little movement we get, we reduce the slop between this pulley and that pulley. This particular transmission has a belt inside, and it will have another bearing set here for this axis here. And we're going to also, this particular bar here that supports the servo will be here as well. And we probably will redesign this knee a little bit. So all of this work is being done because we're entered in the DARPA Robotic Challenge. So for those that, it's not easy. Oh. So the DARPA Challenge is a humanoid challenge against robots like the Atlas, which is made by Boston Dynamics, at $2.5 million a pop. That's what we're going up against. However, we're not tethered like their robot is. We're freestanding and powered internally. So we feel that evolution-wise, we're on the right track and they're not. So that's our robot. Thanks a lot. Anybody that, oh, one more thing.
Yeah, I just wanted to talk briefly. We realized just two guys in a garage isn't going to be enough, and we think a bunch of hobbyists can take on the big boys like NASA, JPL, MIT. So I had the idea to start a meetup group to see if there was any interest in kind of joining us to help us in the Dark Robotics Challenge, and I expected maybe half a dozen people, but ended up with 80 members. So in just a couple of days, it grew beyond my expectations. We actually had a meeting last night to meet a few people, and it went really well. And we want to just open that up to anybody here who wants to join us and take a part in, there we go, in wanting to be a part of the DARPA Robotics Challenge. Some cool benefits. When we do win the $2 million, we will split it. And another idea that I came up with, because a lot of people at the meetup said, well, I want to do my own robotics startup, I want to build my own robot. And we realized if we're going to have a team of people, we need dev platforms. So we decided we're going to make half-sized mini Watsons. And we have a design in mind, a rough idea. It's going to be about $500 in parts, which if you've been pricing even the 12-inch ones, that's a steal. And then to be even better, we are going to Kickstart fund it so that every member gets their own robot. And we will fund it with the Kickstart funds. So if that's not enough incentive, your own robot, share of a $2 million prize, and a backstage or a backstage pass to the DARPA Robotics Challenge where you get to rub elbows with the other teams and Atlas. So join us at the back table where the other our miniature robot is sitting, and come talk to us, and we need your help. And that's it. Thanks.
Our next person will be Cam.
Thank you very much. Hey guys, I know we're all grieving the passing of the Robo games, but in the meantime, we've got the HPRC Challenge Phase 2 next month. And you know you always put it off to the last 2 weeks anyways. So, save yourself 9 months. Go ahead and do what you're going to do over the next 2 weeks and bring it in August. And I'll show of hands, let me think how long for this. Who does not know what is the HPRC Challenge? It's like a Jeopardy question or something. Okay, good. That is not, many people don't know what is the HPRC Challenge, so we're good. August is Phase 2, Bring Your Robots, another opportunity to demonstrate what you've created. In that vein, everybody's seen my robot, Loco Mo, the smart table. I took him to Florida and had him serving candies and whatnot to the family, and vacation was nice. Generally, I'd have a map at this point and I'd be able to demonstrate, but of course, when you go to demonstrate these things, they never work like you expect. Generally, they work better in some odd way. It's like you don't get what you want, you get what you deserve. We got nice tracking on this, Steve. Still no radar map, and otherwise I'd be able to do a mapping. Regardless, so next month is the HPRC Challenge Phase 2, and one of the categories that we have specified is the floor bot. And there really wasn't much participation in the floor bot last month, and I would expect everybody here to be building something, otherwise what's the point, right? So the beauty of the HPRC Challenge is the 101, small robots. Yeah, everybody's seen your robot before, whatever. Dust it off, charge up the battery, give it some love, bring it in and show your robot. Of course, we do the TableBot Challenge. Who here does not know what is the TableBot Challenge? Raise your hand. Not bad, not bad. TableBot Challenge, we got a whole presentation down here. Regardless, next month is HPRC Challenge Phase 2, so bring your robot. And this is Loco Mo, the smart table. Thank you very much.
Okay. Our next person will be Ian.
I start to run on,
Oh.
Well, I'll talk for a moment and then I'll do a little demo and then talk.
Nobody can hear you unless you Cam, bring the wireless in.
Testing. Okay. Good evening, everyone. This is Alistair. Alistair is a Fenn. Let's see if we can get Alistair interested in this little ball here. This is hardware that I brought to Maker Faire. I thought some of the group might not have got a chance to see Alistair there. It's a project I've been working on for a few months. This hardware is a little bit obsolete by this point, but he's a proof of concept, essentially with off-the-shelf parts and a little bit of custom fur and design. He's a pet for the home. He's a connected robot. He does streaming video and audio. I can do remote control right now. The intent is to have a cute, furry robot in your home that you can form an attachment to in place of a pet, or in addition to a pet. And for the geeks out there, what's underneath the fur is a combination of Dynamixel servos, Arduino, a Nexus 4 for the eyes, and a couple other little things, including a Raspberry Pi. So yeah, this is Alistair, and I'm actually looking for other people who are interested in this kind of thing, people who are interested in buying this kind of thing, and anybody else, let me know. My name is Ian, and this is Alistair the Fen.
What?
Well, I can move him a little bit, but I don't want him to like run off the table too much. Yeah. I don't know if you can see that he also has nice little lights on the back, and they're very emotive.
Hi, my name is Ritvik, and I'm going to 6th grade. I made this robot. Well, it's not really a robot. When you click this button, the lights flash and the siren comes. I'm gonna come back here next month, and it'll be a police car that moves around. And is that it?
That's about it? Great. Excellent. What processor?
I'm using the language P Basic 2.5 and Parallax microcontrollers. Yeah.
Okay. I'm squeezing in Dillo next. So Dillo's over there.
Hi. Can you get the screen here on the laptop? Okay, there we go. Cool. So I wasn't actually going to show anything this month until I saw the description of what the topic was going to be on 3D printing, and I wanted to show you something that I've been working on. As you may have noticed, that the robot has been growing slowly, and I've been starting to have a cable management problem. So I made myself a set of cable cleats to wrap the cables around. What this was done in was a program called OpenSCAD. So what you do is you write, rather than manipulating objects and splines and things, you write some code that does some method of modeling called CSG for constructive solid geometry. Other modeling tools call it Boolean operations. So it's the the union of a cube with a disk and a cylinder, differenced with another cylinder going through to create the poles, and you get this thing. So it's 2 parts. This part right here is the actual cleat. So rather than like with a ship or like your iPod cable winder, I actually spaced these out apart so that there is it's not just the cable isn't just wrapped around really tight. There's some strain relief there, so you get bigger loops. So the US, because I'm doing USB cables, you get a little strain relief here. And then the back part is actually, these gaps right here are measured to fit on a Create or on a TurtleBot. So if you have a TurtleBot, these have been designed and printed. They've been designed to fit the spacings on a TurtleBot 1 for the standoffs. Designed it in OpenSCAD. Took it to Tech Shop San Francisco. Used the Type A 3D printer that they have there, which is a type of a PLA printer, and just printed it out. Took me a weekend to get the spacing and the dimensions right and to fiddle with the printer. I mean, because that's kind of what you do with 3D printers these days. It takes some tweaking. But that's basically it. And so now I have, rather than a mess of cables on the back of the robot, I have, it's like a whole lot cleaner, and I can actually see what's going on, and actually, it's just a lot easier to work with. So that's basically it. And if you're interested in the part, let me know. I've got an STL file and an SCAD file. Haven't uploaded it to Thingiverse or anything yet, because I don't know if people are interested, but if there's enough interest, I'll do that. Thank you.
Very good. Okay. So our next robot presentation is right here. If you could stand up over here so we can get on camera.
My name's Bill, and this is Vincent, and this is a little project that he and I have been putting together for the last couple of days. It's a line following robot. Tell me about it.
It was supposed to have a sound thing, but instead it gave us a touch one.
Well, the microphone is not working too well on this right now, but it's brand new, so we're still working on the debugging phase. So did you have fun putting it together?
Yeah,
How long you been putting kits together?
for a while.
A couple of years?
Yeah.
Okay. Here's his robot.
Okay. Nice next one. Okay. Here, I'll take that. And we put it in. Okay, I can't remember if there were any other robots back there that were coming in. I see, no, I don't see any others back there. Are we nearing the end of show and tell? It looks like we're nearing the end of show and tell. There was a gentleman who sent a message to mail us that he was going to show up something called a pick and place machine. No, they just showed up. Okay. Come on down. Yeah.
Yeah. Hi. So my name is Jeff McAlvey. Working with some other folks on a company called Temple Automation, and like for us, we've really been struck by how with software, we be able to just iterate through versions really quickly, and also scale pretty much effortlessly. So iteration is just a matter of going and hitting compile oftentimes, and often you can see the fruits of your work, and so can customers. So also with scaling, using like Amazon Web Services or whatever, you can just go and sort of spin up a couple more computers and get a couple more machines going. So I think one of our big frustrations has been with electronics not being able to enjoy the same kind of thing. And I think oftentimes with electronics, you have to go and send out to some contract manufacturer or try and do it by hand, which turns out pretty tedious. And then also when you're scaling, oftentimes that's a trip to China. So I think what we've been kind of inspired by what's been happening on the 3D printing side of things. So for a long time, it used to be the case that you'd have to spend hundreds of thousands, if not millions of dollars on a big refrigerator-sized robot to go and help you iterate through your mechanical designs. And so more recently, you see companies like MakerBot and things along those lines being able to go and bring that device really much down to a smaller, desktop-sized machine. So the same is actually true with electronics. So you have these big manufacturing lines called pick and place machines as the central ones, and the basis of how they work is you pick up little tiny components and you put them on circuit boards. So just as MakerBot and those folks brought those big refrigerator-sized 3D printers to the size of your desktop, We're doing the same with those pick and place machines. So the workflow is you design a circuit board in software, press pretty much make, and then we go and build out the board. So demo-wise, I don't know the best way to handle it. It takes me like 5 minutes to set up or something like that. Should somebody else talk and I'll demo afterwards, or at the very end, or?
I think we're gonna do that, sorry. I think we'll do the demo after Ted's talk.
Okay.
That gives you plenty of time to do setup.
All right.
And I'm totally fascinated about it because this is my beginnings of a pick and place
Oh,
habit.
brilliant, perfect.
Okay, it looks pretty lethal, but it's just, that's the size the parts came in there. This is a pickup needle, and unfortunately, I've been swamped with work, and this project is semi-stalled right now, but as soon as I clear off my deck a little, I'm going to go back and work on this. So,
Where would I set up?
I'll set up one stable.
All right, so just come track me down here if you want to see this thing in action afterwards. Thank you.
Okay. And yes, it's a robot.